Okay, this starts day 3 of our semester exam review. We're still addressing quadratics, and I want to remind you, whenever they say solve for a quadratic, what you're looking for is the points on the parabola that cross the x-axis. Okay, when they say solve, that's all you're looking for, these points. Sometimes there's 2. Sometimes there's only 1 if it starts on the x-axis. And sometimes there's none if it never touches the x-axis, right? Now, they can call those solutions, they can call those roots, x-intercepts, or even zeros. Those are all vocabulary words that are talking about these points where the parabola crosses the x-axis. So when they say solve, that's all they're looking for. Now I know here it says quadratic formula. That doesn't really apply. We have these calculators and you can type this whole thing in, graph it, go to the table, analyze the graph, everything in the calculator. So that's what we're going to do on these 3 here. So let's go ahead and graph, and we're going to do 6x squared minus 5x minus 7. Remember, when you're finding the solutions, make sure one side of your equation is set to 0 because the y value is 0 when you're on the x-axis. All right? So this one's ready to go. 6x squared minus 5x minus 7, and that fx equals, that fx is my 0. My y is set to 0. Get my parabola. Now looking at it here, and turning on my grid, it's not crossing the grid lines very nicely, right? It's not at a whole number. So the way to get the solutions, because we can't get them from the table, they're not going to be on the table, we can analyze the graph. So you go to menu, you go to analyze graph. Okay, find the 0, option 1. Now you get this little thing you can drag around. I'm going to get close to this right solution. I'm going to click, and then when I drag, it starts bringing this gray area across the screen. I just found it. If you look here, it's 1.57 comma 0. That's my solution. So one of them is 1.57. If I keep dragging, sometimes it gives me the other one. It did. Sometimes it doesn't. Sometimes you have to start again. This one looks like negative 0.741. You can see that, comma 0. So remember, that is the x value of the ordered pair. That's what those mean. Let's go ahead and do number 2. Now number 2 is not ready to put in the calculator. You have to recognize that. I need to move this guy over. So when I do, I get 3x squared plus 9x plus 5 equals 0. All right, I'll go ahead and do that for number 3 also. Let's move both of these guys to the left. So I get 2x squared minus 6x plus 10 equals 0. Okay, so I'm set for both of those now. So let's go ahead and type in my new equation. 3x squared plus 9x plus 5. 3x squared plus 9x plus 5. Okay. There's my new parabola. Again, it's not on the grid very nicely, so I'm going to go to analyze my graph. Go to the 0. There's that. Get over here and drag until I get to that first 0. It pops up. Click it again. It's negative 0.736 comma 0. So I'm going to write negative 0.736. That's only one of them. I need to do the other one. So I'm going to do menu, analyze graph, 0 again. Go to this side. Click, drag, click again. Negative 2. It's a little bit hard to read. I'm going to see if I can move this. See how, oh yeah, you see? If I can't see it, I can grab that ordered pair and move it. It's negative 2.26 comma 0. It looked weird because it was on top of the other one. So negative 2.26 is the other one. That's all there is to it. I'm going to go ahead and start again. This time I'm putting in 2x squared minus 6x plus 10. 2x squared minus 6x plus 10. Okay, I get a new graph. Now notice, this guy's not ever touching the x-axis and it's going that way. How many solutions? No solutions. That takes care of that section. The next section is the same thing. Solve using any method. Well, we've already been using graphing every time, and we're going to keep using graphing for these guys. Find the solutions of the following equations. This one is set to 0, so we're good to go. This one is not, so I'm going to move the 4 that way. End up with 3x squared plus 8x plus 4 equals 0. This one is not set to 0, so we'll move him over. I get x squared minus 81 equals 0. Let's put those in. So I'm going to start it over just to clear out everything. Okay, so x squared minus 2x minus 15. X squared minus 2x minus 15. Okay, turn on my grid. This one looks like it is friendly. Looks like it's negative 3 and then positive 5. Go to the table to verify. Yeah, negative 3 does land on 0. Positive 5 does land on 0. Okay, let's try the next one. I'm going to type in 3x squared plus 8x plus 4. Okay, there it is. That one looks friendly. I think it's negative 2. Let's check real quick. Yeah, negative 2 comma 0. The other one does not look friendly. It's not on the grid. So I'm going to analyze that one. But I can go ahead and write down negative 2 for one of my solutions. The other one, menu, analyze 0. Click, drag, it pops right up. It's negative 0.667. You should recognize by now that's just 0.6 repeating. They rounded it up. It's actually negative 2/3 is what that is. Okay, let's do the other one. Actually, let's not do that. Okay, so I'm going to double click this right and type over it. I'm putting in x squared minus 81. X squared minus 81. There it is, there it is, there it is. Now, we know 9 times 9 is 81. And when you count this, you get negative 9. And then you get positive 9. Those are our two solutions. There you go. Number 7, the directions say, now these are exponential functions, so we're moving on away from parabolas. This is the last function we talked about this year. The functions that look like a sweeping, steepward, upward thing, or steeply going downward like that. Almost down to a flat line, almost. That's what exponential functions look like. Use the table to find the following information. What is the initial value and what is the growth factor? Now the growth factor, we know from exponential functions they move by multiplying each time, whereas linear moves by adding each time. Here, you look here, and you can work backwards. For example, I could start here, and I could do 1024 divided by 256. 1024 divided by 256, I get 4. And again, when I divide 256 by 64, I get 4. 64 divided by 16 is 4. 16 divided by 4 is 4. So you worked backwards. If I'm going backwards, I divide by 4. The factor I'm using to grow going forwards is 4, meaning I'm multiplying by 4. What is the initial value? Well, the initial value is what you have for y when x is 0. I can go back one more time and do 4 divided by 4, and I get 1 right there. Now another way to do it, you can type this entire table in the regression screen. Not the regression screen. In the go to New Document, go to Listen Spreadsheet, and you can type in all the x's, all the y's, label, come up with your graph, do regression, and you would choose option 8, exponential regression. It'll give you the whole equation. Okay? In fact, well, we don't really need to do it because we already have the components of the equation. The equation is set up as y equals a times b to the x power. A is my initial value, b is my growth or decay factor. So I have everything I need, but if you had trouble doing that, you don't like it, do the regression. In the calculator, it'll give you the equation, and then you can work backwards and say, I know this number is my initial and this number is my growth factor. Okay? Let's go ahead and write the equation as y equals, we're not going to write the 1 because the 1 can be invisible. It's going to be 4 to the power of x. We don't need to put it in parentheses since it's the only number showing right there. What is the value of y when x is 7? Well, let's go ahead and type in the equation. Y equals 4 to the power of x. Okay, let me hold on, let me delete all this stuff out. Y equals 4 to the power of x, okay? Now, my graph's fine and good, but I don't really care about it. I'm going to the table. When x is 7, what do I have? I have 16,384. Given the function y equals 30 times 0.5 to the x, complete the following. Now remember, I just explained this number in front is my initial value. This number in front is either my growth or decay factor. If it's bigger than 1, it's a growth factor. Since this is smaller than 1, it is a decay factor. This is a decay function. The decay factor is 0.5. What is the value of x when y is 3.75? Let's take a look. We're going to change this to our new one that we're doing. Y equals 30 times 0.5 to the power of x. We have our decay, we have our exponential decay graph. That's what it looks like. A lot better than my not very good sketch. We go to our table, and I'm looking for 3.75 on the y section. What is the value of x? It's 3. Next, Stan purchased a boat for $12,500. The boat's value depreciates. That means it's getting smaller. It's going to be one of these, okay? At a rate of 12% each year. When you put that 12% in as a rate, you change it to the decimal 0.12 because you move over twice to the left. So my rate is 0.12. How much would the boat be worth in 4 years and 6.5 years? Okay, so let's go ahead and do this. The 4 and the 6.5 are both t values. T is equal to 4, and then t is going to be 6.5. So here's what we're going to do. We're going to type in this. The current value is equal to the principal value. That's this one. Okay. Let's type this in the calculator. Now we can do this on the calculate screen. We don't have to graph this. So the principal value, 12,500, times 1 minus the rate. Okay, so let's go ahead. I know some people were getting errors here. Go ahead and put the times symbol here, the dot, because sometimes the calculator doesn't like the parentheses. It might, maybe it only doesn't messes up on the graph screen. I just think it's a good habit to do that. So 1 minus the rate, and our rate is 0.12, like I just said, raised to the power of t. T is the time. The first one is going to be raised to the power 4. The answer is $7,496.19. Okay? So that's when the t is 4. Okay, let's, I'm going to remind you guys, you can copy and paste. I don't want to type all that in again. So what I do is I go up and highlight that, Control-C to copy, arrow back down, Control-V to paste, and the advantage is I can just change that exponent 4 to an exponent of 6.5. Boom, there's my new answer. In 6.5 years, the value is $5,445.62. There you go. That is the first page of day 3.